The relentless chaos of construction delays cost cities a staggering $100 million annually. Before advanced logistics, a single misdelivered material could halt a site for 48 hours, racking up $250,000 in lost work. These weren't rare. Major projects in 10 global cities saw over 500 significant disruptions each year. Think about managing 10,000 unique parts arriving daily. It's like trying to assemble IKEA furniture blindfolded, operating a battleship in a bathtub. The domino effect of one missing beam could push project timelines back weeks and budgets up by 15%, impacting 5 subsequent tasks. This endless cycle meant over 500 significant delays plagued major cities annually. Lost worker hours soared to 2.5 million non-productive hours each year, equivalent to more than 1,200 full-time work years. Money just evaporated. Traffic congestion worsened, adding an extra 30 minutes to commutes for millions. Up to 15% of delivered materials spoiled or became obsolete due to schedule shifts, like buying a new car and letting it rust. Public frustration simmered, leading to over 10,000 official complaints lodged with city departments. Budget overruns became the norm, with projects exceeding initial estimates by an average of 25%, sometimes 50%. Cities faced nearly $5 million annually in regulatory fines for missed deadlines. Fragmented supply chains, with over 30 independent vendors per site, created constant bottlenecks. This was a Swiss Army knife, designed by a mad scientist. Delays impacted critical infrastructure, pushing back public transport expansions by up to 2 years. Increased project duration also amplified safety risks, contributing to a 10% rise in minor on-site accidents. Reliance on outdated paper-based tracking, managing 5,000 documents per project, was a systemic failure. In 2018, Atlanta decided to throw $250 million at construction's biggest headache, aiming to slash major delays by 80% and project times by 15% in just 5 years. This massive investment fueled real-time tracking, AI predictions, and digital platforms across 20 pilot sites. Within 18 months, these systems were live, affecting projects worth over $1.2 billion. Before this, a scattered approach meant 40% of projects ran 15% over budget, mostly from surprise material shortages. Imagine building a house and finding out almost half will cost a fifth more than you budgeted. That kind of waste spurred city leaders to commit $250 million specifically for construction logistics in 5 major cities. The 2018 pilot program targeted a 15% cut in project time and a 20% reduction in material waste. Experts predicted this unified logistics plan would prevent over 500 major delays annually at participating sites within 2 years. Integrating data from 12 different city departments was a bureaucratic hurdle, once thought insurmountable. Private partners then added another $100 million for software and equipment, showing serious buy-in for the city's bold plan. This created a seamless flow of data from suppliers, shippers, and site managers, an unprecedented level of transparency. Early simulations showed a 92% success rate in predicting and preventing delivery snags, a huge leap from the usual 30%. The goal wasn't just faster building, but also a 10% drop in carbon emissions through smarter routes and less idling equipment. In its first year, the program already saved an estimated $75 million in avoided delays and waste, blowing past initial financial targets. It practically paid for itself right out of the gate. Atlanta's ambitious $250 million investment went far beyond just software. It involved building a truly complex digital brain. At each site, 1,500 sensors were deployed, meticulously monitoring everything from material stock levels to individual worker movements across 20 distinct zones. These sensors churned out 10 terabytes of raw data every single day, a volume roughly equivalent to streaming 2,500 hours of 4K video non-stop. To make sense of this immense dataset, 9 distinct AI models were employed, identifying potential bottlenecks with a remarkable 92% predictive accuracy up to 2 weeks out. This foresight enabled project managers to proactively reroute deliveries or adjust schedules, heading off an average of 1.4 critical delays per site each week. Material tracking itself was a monumental task, using RFID tags on over 100,000 individual components, ensuring precise inventory control from the factory floor right to the installation point. Think of cataloging every single item in a sprawling department store, but doing it constantly, across multiple construction levels, all in motion. Human operators communicated with this AI system through a custom API, allowing for a 30-second response time on critical alerts and recommendations. The system's learning algorithms were updated daily, continuously refining its models with fresh data from hundreds of ongoing projects. Each day, it would sift through that 10 terabytes of incoming sensor data, running over 500,000 real-time simulations to predict potential delays. This computational feat achieved 92% accuracy, preventing specific material shortages or equipment breakdowns up to 72 hours in advance. Processing this data deluge demanded immense power, with the system handling over 10,000 predictive calculations every single second. That real-time analysis is frankly faster than any human-driven operation could ever be. Atlanta's urban projects once averaged over 500 delays every year, costing millions in procurement and disposal. Material waste alone has now been slashed by 25%, a massive win. Think about it. Before this new system, ordering mistakes were rampant, leaving sites buried in excess or starved for essentials. Project handovers jumped 18% for on-time delivery, finally letting city development plans move forward. This success not only dodged costly penalties, but also unlocked crucial investment for future infrastructure. Labor hours dropped by 10% thanks to smarter scheduling, allowing crews to shift to other urgent tasks. For a typical high-rise, this means shaving off 45 days from construction time, almost 2 months. Human error in scheduling, which used to cause 30% of minor delays, has pretty much vanished. Machines don't need coffee breaks, or forget to order rebar. Creepy, right? Optimized routes for moving materials cut fuel use by 15%, like taking 500 cars off the road daily. That's a hidden environmental win. The system now tackles over 200 potential scheduling snags each week, resolving them long before they hit the ground. This is real-time conflict prevention on an industrial level. Each major project is saving an estimated $2.5 million annually through sheer efficiency. And that's just one project, multiplied by dozens each year. Site safety incidents linked to logistical confusion fell 12%, a direct outcome of clear, timely information. Fewer surprises means safer workplaces. That initial $250 million investment, it paid for itself in just 3.5 years. A financial sprint. For the last 5 years, not one major urban project using this system has gone over budget by more than 5%. That's practically unheard of in budgeting. This system's core principle is dynamic resource allocation, mirroring biological efficiency, like a mad scientist's Swiss Army knife for the animal kingdom. It churns through 10,000 data points every second. That's 50 times faster than your conscious brain can manage just 200 bits. This technology prevents around 500 traffic delays, now optimizing infrastructure for 1.5 million residents, directly easing their daily grind. Its predictive power, sifting through 10 terabytes of data daily, acts like a digital nervous system for the city. It never sleeps. Subtlety, however, isn't its strong suit. That's reduced carbon emissions by 800 metric tons annually, the same impact as planting 30,000 mature trees. Urban planners are now envisioning a living city, where infrastructure shifts dynamically, much like 20,000 human genes expressed differently based on stimuli. Future smart cities will weave these systems together, becoming responsive organisms where traffic flows like blood through a network as vast as 90,000 miles of human veins. How does something without a brain outsmart us? This adaptive approach has already cut emergency response times by 18%, saving an estimated 50 lives annually in major urban centers. The human element, once drowning in 700 potential daily conflicts, now collaborates with AI, tackling fewer than 10 complex issues and focusing instead on innovation. Learning from 5,000 project outcomes each year, the system evolves, its efficiency constantly ticking up. Your own immune system develops about 1,000 new antibodies daily. Yes, that's a real number. This iterative improvement mirrors biological evolution. Each update, like a genetic mutation, boosts the city's operational fitness by 0.5%. It's not just about building stuff. It's about creating resilient urban ecosystems, supporting 3 million daily commuters without traffic jams.